In this video, I am going to discuss H2O Lewis structure or water Lewis structure, then H2O formal charge, H2O hybridization, then H2O molecular geometry or shape, or H2O Lewis structure polar or non-polar, that is H2O polar or non-polar, then H2O Lewis structure with octet rule, then H2O bond angle. So you'll much more information if you spend here. I think you will be confident. So let us draw the Lewis structure of H2O, because this will help us to explain all the things. So to draw the Lewis structure of H2, you have to find out the valence electron of H2. You know that hydrogen is an element of group A, group 1A, that is why it has one valence electron, but here we have two hydrogens, so we have to multiply by 2. Oxygen is an element of group 6A, that is why it has 6 valence electron, right? So if you add them, you will get 2 plus 6, 8 valence electron. So how many valence electron does H2 have? The answer is the 8 valence electron in H2O or water. This 8 valence electron has two tasks at the same time. The first task is to connect these two atoms together, right? You know that hydrogen is always considered as outer atom. So to connect, you have to put just 2 dots, right? 2 dots. So after connecting these 3 atoms, you have 8 minus 4, that is you have 4 valence electron left. This 4 valency will be used to satisfy the octet of oxygen, and you know that hydrogen already fulfill its outermost shell, that is hydrogen has obeyed the duet rule, right? So this 4 electron will come over oxygen, right? Okay, now look, we have used here 8 valence electron. So this is the Lewis structure of water, right? So now I am going to show you the formal charge for each of atom in water molecule. So let us find the formal charge for this hydrogen. So we know that formal charge equal to valence electron in a neutral molecule minus half of bonding electrons minus lone pair electrons, right? So let us apply for this hydrogen. So in a neutral atom of hydrogen, we have one valence electron. Then we have to consider half of bonding. Here bonding is 2, so 2. Then lone pair of hydrogen. There is no lone pair of hydrogen. So 1 minus 1, that is 0, right? So the formal charge of hydrogen in water molecule is 0. So this hydrogen and this hydrogen are staying in similar electronic environment, so these hydrogens formal charge will be also 0. So now let us find out the formal charge for oxygen. So in a neutral atom of oxygen, we have 6 valence electron, then we have a half of bonding electrons. Bonding here 2 4, that is half of 4, then minus lone pair. Here we have 2 to 4 lone pairs. So 6 minus 2 minus 4, that is 6 minus 6 equal to 0. So this oxygen has 0 formal charge, right? So let me show you the another way to find out the formal charge for hydrogen atom and oxygen atom in water. So what is that? Look, for finding the formal charge of oxygen, look, we know that in a neutral oxygen we have 6 valence electron minus, here we have assigned how many electrons. We have to count lone pair totally, so 2 4, and then we have to take a half of bonding. So here we have to consider 1, from here we have to consider 1. 2 4 5 6, right? 0. In hydrogen, we know that in a neutral hydrogen atom we have 1, but here we have assigned 1, so 0. So this is the easy trick to find out the formal charge, right? So now let me discuss about the hybridization of oxygen atom in water, that is H2O hybridization. That is why we have to have knowledge about steric number, that is electron region, right? So here we can express this molecule like this, right? Look, here we have electron region, here sigma bond, sigma bond, sigma bond. So here 1 electron region, 2 electron region, 3, then 4. That is, here this water molecule has 4 electron region, that is its steric number is 4, right? So you need 1 s orbital and 3 p orbital. So the hybridization of oxygen atom in water is sp3, right? So due to sp3 hybridization, the shape of this molecule should be tetrahedral, right? Tetrahedral. But look, here you have lone pair over oxygen, right? Over oxygen. So what will happen? You know that due to presence of this lone pair, the bond angle for in tetrahedral, the bond angle should be 190 degree, right? But due to presence of lone pair, this bond angle, the actual bond angle is 4.5 degree. That is, this is the distorted structure of water due to presence of lone pair. The structure of water like V-shaped, right? And the angle between hydrogen, oxygen and hydrogen is 104.5 degree, right? So the hybridization, the bond angle and the shape already we have discussed. The shape of this water is bent, that is V-shaped. The hybridization of oxygen is sp3, and according to hybridization, the ideal shape or molecular geometry of water should be tetrahedral, but due to presence of lone pair, we have V-shaped geometry of water. So if I ask you how many bondings and lone pairs electrons are present in water, so you have 2 lone pairs and 2 bonding pairs. So in water you are getting 2 sigma bond, right? There is no pi bond in water. I hope you have now cleared about all the things for water Lewis structure. So now I am going to tell you the H2 molecule's polarity, right? So let us, you know that polarity depends on many things. First, let us check the bonds polarity. Look, here oxygen is more electronegative than hydrogen. So this hydrogen is partially positive and this oxygen is partially negative. Partially positive, partially negative. So look, these bonds, the electronegativity difference, due to electronegativity difference, this bond is polar, this bond is also polar, right? So this bond will have a dipole moment and the direction will be from hydrogen to oxygen. Since this bond is polar, so this bond also will have a dipole moment, right? Dipole moment, due to band structure, this dipole moment and this dipole moment doesn't cancel each other, so you will have a net molecular dipole moment for water. That is why we can say that H2O is a polar molecule, that is it has a positive it has a net dipole moment. I think it is clear to you now. So thank you for viewing this video. Be well.